Morning all. Myself Durga Prasad from the Maths faculty. Today I will give a short demo on section formula. This is very important. So first of all, what is the use of section formula? You can see here there are two places. The first place I am naming as A and another place is B. You can think these two are the cities. So in between them another place is there. For example, I am making as P. So if you want to exact location of P with respect to the columns and rows, if you want to find the exact location of P, this section formula will help you more. So how the formula will derive? So I will explain. So you can see here, this is the place A. So this is the point A. I am taking as x1, y1, and another point B, that is x2, y2. So we have to find the exact location of P. So I am taking P as x comma y. So, and one more thing is the distance between A to P is m units and P to B is n units. Now our task is find the coordinates of the point P. So that's why I drawn the coordinate axis. The horizontal axis is x-axis. The vertical axis is y-axis. This is the origin point. So after that, I drawn the perpendicular bisectors of every point. So I drawn from A to here, this is named as D, and B to x-axis, it is named as E, and N to B to F, I named as F. So AD, ME, and PF are the perpendiculars to the x-axis. After that, so here we can see DE is the particular distance on x-axis. I drawn a parallel line which is AM parallel to DE, and one more, and DEF is the fixed distance. I drawn another line, that is PM, which is parallel to EF. So if I join AP already joined, so AM and PM if I join, we can get a right angle triangle. Same like that, and one more triangle is that BPM. If you observe the two triangles here at M and at N, those two angles are the 90 degrees. So I am writing here for the better understanding. In triangle APN, triangle APM and BPN, angle M is equal to angle N is equal to 90 degrees, because those two are the right angle. So here AM and PM are the parallel lines and AP is the transversal. By the transversal properties, these two are the corresponding angles. The measure of corresponding angles are equal. So we can write as angle A is equal to angle P. Why they are equal? So we have the property about the transversal is that these two are the corresponding angles. So the measure of corresponding angles are equal. So you can see here angle M is equal to angle M, angle P is equal to angle A. That means the given two triangles, those two are APM and triangle BPN are similar. They are the similar triangles. So now we can extend the similarity properties. Actually, what are the similarity properties? There are two important properties. What is that? First one is corresponding angles are equal and the sides, the ratio of the corresponding sides are equal. So now we can write the ratios of these two triangles, sides. What are they? In the first triangle AP and the second triangle BP. Those two are the corresponding. So I am writing the ratio of them. What is that? AP by PB is equal to, here you can see, this is in this triangle AM is corresponding to PM. So AM by PM is equal to, in the first triangle there is PM, in the second triangle we have BM. So we can say that PM by BN. So this is the corresponding sides ratio. Now we can find the values of AP, PB, AM, PM, PM and BM. So from the diagram you can see the length of AP as M and the length of PB is N. So we know the values of AP and PB. AP is M, PB is N. Now we can go with A. AM is equal to, first of all, where it is. So here this is the point A, this is the M. So the distance between them, A and B is AM. We have to find the distance of A. So from R is into E, we are taking as X, and R is into D is X1. If you subtract OE minus OD, you can get DE. So OE is X and OD is X1. If you subtract them, we can get AM. So AM is X minus X1. The same like PM. Go to PM. Where is PM? Here is the PM. So it is between OF. The length of OF is X2 and the length of OE is X. If you subtract them, you can get X2 minus X. So PM is X2 minus X. And same like PM is equal to, where we have PM? Yes, PM is here. So now we can take on y-axis. From x-axis to P is y and x-axis to M is y1. If you subtract them, you can get the PM value, that is y minus y1. The same way, we have to find the value of Bn. Where is Bn? So here we have Bn. From x-axis to B is y2 and x-axis to N is y. If you subtract them, you can get the B value, that is y2 minus y. Now you have all the values. Now we can substitute now. The value of AP is M, PP is N is equal to, here AM is X minus X1 and PM is X2 minus X. So, and same time here, PM is Y minus Y1 by Y2 minus Y. So, I wrote the ratios first. Now I have substituted the values. You can see M by N is equal to X minus X1 by X minus X1 by X2 minus X, as well as Y minus Y1 by Y2 minus Y. It is nothing but 1 is equal to 2 is equal to 3. What does that mean? If 1 is equal to 2 is equal to 3, then we say that 1 is equal to 2 as well as 1 is equal to 3. So now I am equating 1 equal to 3. That means M by N is equal to X minus X1 by X2 minus X. Now do the cross multiplication. So M into X2, Mx2, M into X, Mx is equal to, same way here, N into X, Nx, N into X1, Nx. Now I am taking X's are in one side and the remaining are on side. That means I am changing Mx to be here and taking Nx1 to be here. That means Mx2 plus Nx1 is equal to Mx plus Nx. If you observe, we want the value of X. So in the RHS we have Mx and Nx. So I am taking X as the common. That means Mx2 plus Nx1 is equal to X of M plus N. We want X, that's why transposing this term to here. So this is completely Mx2 plus Nx1 by M plus N is equal to X. Similarly, if you equate X M by N is equal to Y minus Y1 by Y2 minus Y, you can get the value of Y is equal to My2 plus Ny1 by M plus N. Finally, so we want to find the value of the coordinates of P. P we are taking as P of X comma Y. That is P of, what is the value of X here? The X is Mx2 plus Nx1 by M plus N, comma, and the second one is My2 plus Ny1 by M plus N. So finally we found the exact location of the point P. So this is the derivation of section formula. Thank you.